Hi you guys, I am ready for lesson 3 of module 17. I am super excited for this lesson because it is just about solving problems, and we have done word problems and story problems all year long, and so now we're doing basically that same thing using all of those great strategies that we've learned, but just with the context or lens of volume and mass. So things like using a bar model and drawing a picture and writing out multiplication equations or addition equations, things like that that we've done all year long is what we're gonna do right now. And so I'm super excited. I know you guys are gonna do really awesome on this. Again, the only difference is that it's in that lens of mass and volume. And so instead of saying like, oh, plates of cookies, like some of the other story problems that we've done would talk about, it'll talk about the weight of objects, or if one object weighs this many grams, then how many would a box of 5 of those objects weigh? And so then you'd have to multiply. So does that make sense how it's same process, same strategies? We're just looking at it like mass and volume. So I'm super excited. So you should have your workbooks out on page 447. And again, the title of this lesson is Solve Problems About Liquid Volume and Mass. The I can statement says, I can solve word problems that involve liquid volume and mass. So same thing. All right, the step it out. We're skipping the Spark Your Learning. We are going right to the step it out because we are mathematicians and we got this. So the step it out says, Ava fills the 100-liter container to the mark shown to water a garden. She will use water from the 100-liter container to fill the empty pan on the right to the top mark. Part A says, complete the bar model to show the amount of water in each container after Ava fills the pan. So let's look at these pictures. The top mark of this little pan goes up to 25. So I know that if I fill this all the way up, this pan is going to be filled with 25 liters of water. So that is going to go in one of the boxes. Okay, and then the total amount of water is in here. So let's take a look. We're counting by 20, so this would be 20, that next line would be 40, and then 60 is written, and then it would be 80, and then 100. See that? So the line is not quite to 80 yet, but it's above 60 and it's above 70. I was counting by like 5s and saying 10. Anyways, and so this is at the 75 mark. So this one is 75 liters. So that's all we know right now. So since this is our bar model, this is our total, this is what's going to be filled in this small container, how much is going to be left in this container after I pour 25 liters into the small one? Well, that would be a subtraction problem, and so I would do 75 minus 25 equals, okay, when I see 25 and 75 like that, I'm thinking of quarters. So how many quarters is, 75 cents, how many quarters do I need to make 75 cents? 3, how many quarters is 1/25. So basically I'm saying 3/4 minus 1/4 is 2/4. What's the value of 2/4? And that's 50. Okay, pause. You might be thinking, what on earth, Miss Lowenquist, where did quarters come from? So remember how I use like little tricks and things that remind me of like real life connections to do the addition or subtraction problems easier. So like when I see 45, 30, 15, that makes me think of a clock. When I see 25, 75, 50, that makes me think of quarters. And so then it's like, oh, I'm just counting quarters. What's the value of the quarters? And so then I could do the subtraction problem easier. If you don't want to use that connection, totally groovy, just write out the subtraction problem and you'll still get 75 minus 25 equals 50. You'll get the same thing. But I find that making those connections to real life things helps your real life application, and it just helps the math as well. So, part C says, how many liters of water will be left in the 100 liter container, the big one? So how much is left? 50 liters. So that's what would go in that box. We could have put a variable there because it was an unknown number, but we solved it, so we just wrote it in. Okay, the turn and talk says, how did you decide what equation to write to solve the problem? How did I know that this was going to be a subtraction equation? Well, I knew it was going to be a subtraction equation because I started with this fixed amount of water, right? I'm not adding any water to this container. I am simply removing it from the big container and giving it to the small container. And so then I would want to know how much is left, and that is the key phrase. How much is left? That tells me I'm doing subtraction. So we look for those key vocabulary words, and we took lots and lots of notes on this when we were doing word problems. We find those key words, and that helps us know what operation to use. And operation is addition, subtraction, multiplication, and division. So how do we know which one to use? We look for our key terms. So hopefully this is sparking a memory, and you're like, oh my gosh, yes, of course, we did this all the time. So I'm excited. Okay, number 2 on the next page, it says, Pete ships a care package to his brother at camp. The mass of the soap bar is 58 fewer grams than the mass of the tube of toothpaste. What is the mass of the tube of toothpaste? Okay, so this is a story problem. What's the first question I asked myself? What do I need to find? What do I need to find? I need to find what is the mass of the tube of toothpaste. What information am I going to use? I am going to use that the mass of the soap bar is 58 fewer grams than the tube of toothpaste. So let's go through the steps. It says, what information is unknown? The unknown information is in the question. The unknown information is the mass of the toothpaste. Then part B says, use the information in the problem to complete the bar model. So the soap is how many grams? So the soap is this, see it how it's on the pan scale? And they're perfectly equal. So that means these are grams, and we use this many grams to get to the weight of the soap. And so when it's perfectly balanced like this, that means that the soap weighs this amount of grams. So we just have to count this up. So I'm going to start with the 20s, 20, 40, 60, and then the 10. So now I have 60 plus 10 is 70. 70 plus 5 is 75, 76, 77, 78, 79. So the soap weighs 79 grams. So that's what I'll write there in the soap part. And then it says that the mass of the soap bar is 58 fewer grams than the mass of the tube of toothpaste. So here's my full toothpaste. So the toothpaste is the weight of the toothpaste is the weight of the soap plus 58 grams, right? Because the soap weighs 58 fewer than the toothpaste. So I will put 58 there. So see that? So soap weighs less than the toothpaste by 58 grams. use the bar model to write an equation to solve the problem. Okay, so if I know 2 parts and I don't know the total, that is going to be addition, right? So I'm going to say 79 plus 58 equals, we'll solve it. I'm gonna do some regrouping. So 79 is really close to 80, and that would make 58. I'm gonna take 1 away from 58, give it to 79, make it 80, and that will turn 58 into 57. Then I'm gonna add up the 10s, so 80 plus 5 10s, so 80 plus 50 is going to be 130, plus 7 1s is 137. So what is the mass of the tube of toothpaste? 137 grams. Again, how do we know which equation to use to solve the problem? Well, if we look at our bar model, we're trying to find the total weight of the toothpaste. We have 2 parts, so we add those 2 parts up to get our total weight of the toothpaste. All right, next page, number 3, it says, Pete ships some markers to his brother at camp. Each marker has the mass shown. What is the mass of 6 markers? So, this is a story problem. What do I need to find? What is the mass of 6 markers? Okay, what information am I going to use? I'm going to use that each marker has the mass shown. And so I'm going to use this scale. Again, the scales are exactly the same like height. They're perfectly balanced. So that means this marker weighs this many grams. So I'm going to count it. 5 grams plus 1, 2, 3, 4. So this is 9 grams altogether. So 9 grams, I just did 9 grams like that. That is for 1 marker, but I want to know what is the mass of 6 markers. So what am I going to do? I'm going to draw this 5 more times so I have 6 total. 9 grams, 9 grams, 9 grams, 9 grams, and 9 grams. Ta-da! So now I have 6 of them. Then it says, complete the bar model to represent the problem. So let's count. How many boxes do I have? 1, 2, 3, 4, 5, 6. So that tells me the number of groups because I have 6 markers. How much does each marker weigh? 9 grams. So I'm going to put 9 in each of those boxes. Okay, 9, 9, 9, 9, 9. Write a multiplication equation to represent the problem. Well, I have 6 markers. Each of them weighs 9 grams. So 6 times 9, do we remember our facts? 6 times 9 is 54. So then that 54 would go at the bottom of the bar model for the total of all the markers. So what is the mass of 6 markers? 54 grams. It says, describe the visual model and the equation you use to solve the problem. So here's our visual model, here's the bar model. We drew 6 boxes. Each box had 9 grams in it. So the boxes represent 1 marker. Each marker weighs 9 grams, so each box has 9 grams inside. All right. Okay, the next page is the check understanding. It says, write an equation and solve the problem. Han packs a total of 72 grams of construction paper sheets in an envelope. He packs 9 sheets. What is the mass of each sheet? This is for a problem. So first question I ask myself, what do I need to find? I need to find what is the mass of each sheet. So that's what I put in a box. What's the next question I ask myself? What information am I going to use? I'm going to use that he packs a total of 72 grams of construction paper and he packs 9 sheets. What is the mass of each sheet? Okay, so then I want to think about what does each piece of evidence represent? So what is the mass of each sheet? That is my number in each group. The total of 72 grams is our total. That one totally gave it away. And then if he packs 9 sheets, that's my number of groups. So how do I know which kind of equation to write? I know my total. I know my number of groups. I'm trying to find the number in each group. So what operation, if I know my total, I know my number of groups, I'm trying to find the number in each group. That's my division equation. Okay, so I'm gonna start division. We always start with our total. Our total is 72. Okay, then we're gonna divide by the number of groups because that's the part that we know. So 72 divided by 9 equals, okay, remember my math facts. What number times 9 would get me to 72? 72 divided by 9 equals 8. And it's not just 8, it's 8 grams. Right? 8 grams. How do I know it's 8 grams and not 8 sheets of paper? Well, the question tells me what my units are. What is the mass of each sheet? So I'm trying to find the weight and I'm using grams. All right, number 2, it says Jen fills 6 bottles with milk. Each bottle has 3 liters of milk. How many liters of milk are in 6 bottles? This is a story problem. First question to ask myself, what do I need to find? I need to find how many liters of milk are in the 6 bottles. What information am I going to use? I'm going to use 6 bottles of milk. Each bottle has 3 liters. Now again, I want to think about what does each piece of evidence represent. My 6 bottles, that's my number of groups. Each bottle has 3 liters. That one kind of gave it away again. That's my number in each group. And I'm trying to find how many liters of milk are in the 6 bottles all together. So I have my number of groups, number in each group, trying to find the total. What operation is that? Multiplication. So I'm going to multiply my number of groups, 6, times the number in each group, 3 liters, equals, we know our math facts, 6 times 3 is 18 liters of milk altogether. Remember your units. All right, number 3 on your own, it says, Jamal's car has a full tank of gas. Then he uses 24 liters of gas. There are 16 liters of gas left in the tank. How many liters of gas are in a full tank? So this is a story problem. What's the first question I ask myself? What do I need to find? I need to find how many liters of gas are in a full tank. What information am I going to use? I'm going to use that it was a full tank, then he uses 24 liters, and there are 16 liters of gas left. So it's full, he uses 24, and now there's 16 left. So I want to know how many liters of gas are in a full tank. Write an equation to solve the problem. What operation am I going to use? Well, I have these 2 pieces of information. If I add those pieces of evidence, I would get my full tank. If I say, okay, he uses, if I were to draw it out in a bar model, I would say he uses 24, has 16 left. My total would go at the bottom. Right, like that. Oh, it's so tiny. 24, 16 gives me my total. So I'm going to say 24 plus 16 equals, oh my goodness, I see 2 best friends, 4 and 6. 4 and 6 make a 10. So I'm going to take those 10s, or take 6 and 4, make a 10. Now I have 20 plus 10 plus 10, and that gives me 40 liters of gas. So the L is for liters. So how many liters of gas are in a full tank? 40 liters of gas. Yay! All right. Number 4, an ice cube has a mass of 28 grams. After it is left out on a warm counter, it has a mass of 13 grams. How many fewer grams of mass does the ice cube have after being left on the counter? Write an equation to solve the problem. So this is a story problem. What am I trying to find? I want to know how many fewer grams of mass does the ice cube have after being left on the counter. Okay, you might be reading that and you're like, oh my gosh, what is it even trying to tell me? So let's break it down. How many fewer grams of mass does the ice cube have after being left on the counter? What's another way we could say that makes sense in our brain? After we're picturing this in our head, the ice cube is left out on the counter. It started with a mass of 28 grams. Now it has a mass of 13 grams. So we're trying to find how many grams it lost, right? Started with 28. Now it's 13. How many grams did it lose? That's another way to say this question. So what kind of equation will I do? Well, I will do a subtraction problem because I started with 28. Now it's 13. So I want to know how much it loses. So I can do 28 minus 13, and that will give me 15 grams. So it lost 15 grams. Okay, next page. The On Your Own is a little bit longer in this lesson, but that's totally okay because we're Rockstar students. Number 5 says, each ball of yarn has the mass shown. Esther buys several balls of yarn that have a mass of 56 grams. How many balls of yarn does she buy? Complete the bar model to show the problem. So this is, start by annotating our story problem. So the first question I asked myself, what do I need to find? I need to find how many balls of yarn does she buy? Okay, the information I'm going to use is that each ball has the mass shown. So that's right here in our picture. And Esther buys several balls of yarn that have a mass of 56 grams. So what does each piece of evidence represent? My 56 grams represents my total. The mass shown here, that is my number in each group. And I'm trying to find the number of groups. I'm trying to find the number of balls of yarn. So those are my groups. Okay, so the first part is blank balls of yarn. I don't know how many balls of yarn she purchased yet, so I'm going to fill in what I do know. I do know that each ball of yarn weighs this amount. 5 plus 1 plus 1 plus 1. That would be 8 grams. So 8 grams goes in every box. Do I know how many boxes to write? No, because I don't know how many balls of yarn she bought. So I'm just doing this to kind of see it visually. So then what is the total of all the balls of yarn? They all weigh 56 grams. So if I know my total, I know my number in each group, I'm trying to find my number of groups. What operation is that? Division. So I start with my total. 56 divided by 8 equals 5, 6, 7, 8. Remember that trick? Every time I see 56 and 8, I automatically think 7, right? 5, 6, 7, 8. That's our trick. Okay, so 56 divided by 8 is 7. So Esther buys 7 balls of yarn. Woohoo! Okay, number 6. A shower uses 7 liters of water in 1 minute. How many liters of water would a 7-minute shower use? Explain how you found your answer. So, I'm trying to find how many liters of water would a 7-minute shower use. Okay, a shower uses 7 liters of water in 1 minute. Okay, so I know my number in each group, my liters per minute, that's number in each group, and my groups are my minutes. And in this case, we have 7-minute showers. That's a quick shower. So I'm just writing my notes on the side because that helps me keep track of everything that I'm doing. Number in each group is 7. Number of groups is also 7. So if I know my number of groups, I know my number in each group, I'm trying to find the total. That is multiplication. So I'm going to do 7 times 7. Oh, doubles fact. 7 times 7 is 49. So how many liters of water would a 7-minute shower use? 49 liters of water. And then you'll explain how you found your answer. We found that answer by asking ourselves, what do we need to find? And then looking at each piece of evidence and knowing what they represent, knowing that if I have my number of groups and I have my number in each group, that is multiplication. So I do my multiplication equation. All right, number 7 is open-ended. It says, write and solve a word problem about the mass of some paintbrushes. And so here you have another pan scale. You have one paintbrush and the weight is over on the other side. They're balanced, so that tells us that this is the true amount. 5 plus 1 plus 1 is 7 grams. So each paintbrush is 7 grams. So you'll write your own story problem about this. You could say the mass of the paintbrush is shown. If I had a cup of 6 paintbrushes, how much would those 6 brushes weigh all together? Or, you know, something like that. Something with paintbrushes. It could be addition, subtraction, or multiplication or division. So let me know what you come up with. Okay, last page. Number 8, it says, Naomi is shipping packages to customers. Each package has a mass of 4 kilograms. There are 7 packages. What is the mass of the 7 packages? So I need to find what is the mass of the 7 packages. The information that I'm going to use is that each package has a mass of 4 kilograms and there are 7 packages. So now I need to think about what each piece of evidence represents. My 7 packages is my number of groups. And then each package has a mass of 4 kilograms. That is my number in each group. And then, so what is the mass of the 7 packages? That's going to be my total. So what operation do I use if I know my number in each group, I know my number of groups, trying to find the total? That's multiplication. So my number of groups is 7 times the number in each group, which is 4. I know my math facts. 7 times 4 is 28. So the mass of the 7 packages is 28 kilograms, right? Because we're using 4 kilograms here. Switching it up a little bit. Okay, number 9, it says, if Terry places a package of crackers on the left pan, the 2 pans will be balanced. What is the mass of the package of crackers? This one is fun. Okay, so we're comparing these two, the 2 weights on the pan scale. So you can see that they are not balanced. But this is saying that if Terry places the animal crackers onto this side, then it will be balanced. So then I'm going to use that information to figure out how much the box of animal crackers weigh. So let's count up here and see how many grams is on the right side. 20 and 20 is 40. 40 plus 10 is 50. 50 plus 5 is 55. 56, 57. So over here is 57 grams. Over on this side is 10, 5, that's 15, 16, 17, 18 grams. Okay, so basically what we're saying is the animal crackers plus 18 grams equals 57 grams. So I'm going to do a box, because I don't know the weight of the box of crackers yet. plus 18 equals 57. Now, I want to rewrite this in such a way that will give me the answer. So I'm going to use my fact families, and I'm going to say I can rewrite this as 57 minus 18 equals the box. So then I have to solve 57 minus 18, and so I'll do that here. 57, if I do, let's see, 57, I'm getting all tongue twisted. If I move 1 over, this will be 58 minus 17, and then I could do minus 1, or no, that's not going to work. I'm going to do 50, I'm going to break it up. 50 and 7 minus 10 plus 8. So then I would do, I have to regroup this to 40 because 7 is not enough to take away 8 from. So now I have 40 plus 17 minus 10 plus 8. So then I do 17 minus 8, and that's 9, and 40 minus 10, and that's 30. So the weight is 39. Woo, I went all over the book. 39 grams. Okay, awesome, awesome. Number 10, it says, a kiwi fruit has a mass that is 67 grams more than the mass of a strawberry. The mass of the kiwi fruit is 83 grams. What is the mass of the strawberry? So what I'm trying to find is, what is the mass of the strawberry? Okay, and then the information that I'm going to use is that the kiwi fruit has a mass that is 67 grams more than the mass of a strawberry, and the mass of the kiwi fruit is 83 grams. So what is the mass of the strawberry? So basically what I'm saying is the kiwi fruit, okay, so if I'm picturing this in our head, reading this out loud, the kiwi fruit has a mass that is more than the mass of the strawberry. So the kiwi fruit is bigger by 67 grams. And so if the kiwi fruit is 83 grams, I would take 83 minus 67, and that will give me, I have to regroup again. So instead of saying 83, now I'm going to say 70 and 13 minus 60 plus 7. 13 minus 7 is 6, and 70 minus 60 is 10. So then I have 16. So the mass of the strawberry is 16 grams. Okay, last one. It says a soccer team has an 18-liter water cooler. Each player has a 2-liter water bottle. Write and solve a problem about the water cooler and the water bottles. So this one, kind of open-ended again. It says write and solve a problem about the water cooler and the water bottles. Here's what you have to be careful about. The team has an 18-liter water cooler. That's my what? My total. Each player has a 2-liter water bottle. That's my number in each group. So that's what I need to be very careful about. And so if I know my total and I know my number in each group, that's sounding like division. And so your problem is probably going to be about division. So if I were to do this, I would say each player has, I would basically say those first two sentences and just rewrite it. A soccer team has an 18-liter water cooler. Each player has a 2-liter water bottle. If every single player got water from the water cooler and there was none left, how many players are on the team, or how many players got water from the water cooler? And then that would say, 18 divided by 2 would get you 9. So there are 9 kids who got water from the water bottle, or from the water cooler, to fill their water bottle. All right, that was all. I hope that went well. It was kind of a fun review because that is stuff that we've done all year long. So kind of cool to come back to that and do it in a different lens of doing volume and mass. So I hope it went well. Work on your homework. We're going to do the review and test tomorrow. So good luck, and let me know if you need anything. Love your guts. Bye.